All right, so let's start our lecture today. So, um, yeah. Anyway, I kind of hear us. Okay. Um, okay. So let me open my uh the document from last time. Um, okay. So yeah, last time. So okay. So holomorphic equivalence of holomorphic copies with the same image fundamental group. Um. Okay. So okay. I think. Okay. So um. Okay, so I think by the let me check here. So by the corollary 5.1.4, by the 5.4, check 5, uh, okay, so yeah, so let me paste it here. Oh, it's here. Okay, okay, yeah. So let me paste the other part. So there's another part of this theorem that's not being pasted. So I gotta paste it here. Okay. All right. So okay, so here it says, okay, so we have a such structure, okay, and then okay, so these are like the base point, okay, and then moreover, if I have uh wait, why am I doing this? Okay, so okay, so if I have the gamma push forward of pi one x hat x naught hat, right? So the gamma push forward of the fundamental group here and then it's equal to the gamma check put forward of the fundamental group. So for example, you have a X naught check at this point, right? And then um, the conclusion is that if these two are the same, then this gamma hat is a biholomorphism. That is, the two covariants are holomorphically equivalent. Okay, so in our case, uh, so here, what is the two cover that we have? Uh, uh, okay, so polymorphic. Wait. Okay, I think this phrase that I messed up. So the two covariants are holomorphically equivalent. Space. Uh, so then I have two holomorphic equivalent and homomorphic covariant spaces. There are a holomorphic covariant surface check. Oh, Okay. There is a uh, okay, I think the idea here is that um so this x and this x hat. Okay, so instead of okay, so I think instead of composing the uh file with the gammas, like sorry, gamma deck, I'm composing in this way. So I'm composing the uh mm, okay, so here I start with the x here, and then I just directly do the x hat, which is yeah, so which is being defined as a quotient by the subgroup gamma, and then uh we define to be the uh phi composed with gamma hat. Okay, so and then uh and then the covering map is exactly given by the phi composed with gamma deck of this X tutor. And then this map is the same. Yes. So that is a map. Okay, so that is a map. So uh yeah, so we've shown that this is actually so I'll call this whole thing gamma hat instead of phi composite gamma hat. So this whole thing is gamma hat. And then the gamma hat push forward. Um, let's call it gamma hat. Yeah, the gamma hat push forward is yes, it's called gamma hat prime. So the gamma hat prime push forward is exactly equal to the uh gamma hat. Sorry, it's gamma hat prime push forward composed with the yeah. So composed with uh I think that's the other way, right? So I think no, it is this way. Okay. So this is exactly the gamma hat push forward, and then that's composed with the phi push forward. So when you plug in a rule, then that is equal to an element that is equal to A to B. Okay. 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 Yeah, that's the same. So yeah. So and then yeah. So we show that this family group are already match the property. So therefore, this is true. Okay. And then yes. Yeah, up to holomorphic equivalence of holomorphic covering spaces. There is a unique surface. gamma hat of xi to x and a point. Okay. Um, okay. So, okay. Yeah. Yes. Yeah, I think we have it. think so. Uh, yes, up to the holomorphic equivalence of holomorphic space. Yeah, so there is a unique um uh so y up to holomorphic equivalence. Um oh yeah. So if we have another one, right? Then okay, yeah, I see. Okay. Yeah, so if we have another one, so they by this definition they are uh yeah, so if there is another one, so then by the corollary 10.4, 5.1.4, so this corollary here, yeah, so this corollary here, we would have the property that the inclusion of the pair ones, uh, yes, they're exactly the same. So therefore, it is contained in each other. So therefore, they are actually they're the same. Yes, actually they're the same. So therefore, this gamma hat is a biholomorph. Yeah, so actually it is a biholomorphism. Yeah, so the existence of this gamma hat is given by the first part of this corollary, and then the second part is the equality. The second part, like so here we will have the equality, right? It's because we require the image to be exactly the same onto this gamma, right? So because yeah, so both are onto gamma, so therefore we have that. Okay. All right. Yeah. So yeah. So that's the proof of the corollary 5.1.8. So and then so uh yeah. So in the next lecture, I will continue with example of universal holomorphic corollary space. Okay. So I'll continue next time. Okay. Thanks.